Every year, the United States produces and processes millions of pounds of wool, fueling an industry quietly valued at $555.6 million and supporting thousands of farms across the country. But despite its size, most Americans have no idea where their wool comes from, or that the industry is shrinking faster than many other agricultural sectors. So what keeps this hidden market alive in an economy dominated by synthetic fabrics and cheap global imports? Today, we trace the real story of American wool, from shearing sheds to grading rooms to the manufacturing pipelines that keep the industry moving. This is the $555.6 million U.S. wool market hidden in plain sight from start to finish. The U.S. wool market begins at the farm level, where more than 5 million sheep contribute to the country's annual wool supply. Wool is harvested once a year through shearing, a process that removes the fleece without harming the animal. Each fleece contains layers of fibers with different qualities, from fine merino-style strands used in high-end apparel to coarser grades used for carpets, blankets, industrial textiles, and insulation. Globally, wool competes in a marketplace dominated by synthetic fibers like polyester, which are cheaper to produce and faster to scale. Yet, natural wool retains a strong market profile because of its durability, fire resistance, biodegradability, and moisture-regulating properties, traits synthetics struggle to replicate. These characteristics keep wool relevant across apparel, home goods, military fabrics, and specialty technical products. The United States contributes only a small percentage of the global wool supply, with countries like Australia, New Zealand, China, and the UK leading international production. However, U.S. wool maintains high value due to strict grading, consistent quality, and demand from specialized textile sectors. Much of America's wool is exported in raw or semi-processed form to international mills, where it becomes apparel and fabrics later re-imported into the U.S. retail market. This global circulation highlights the importance of wool as a raw material. Its pricing is influenced by weather patterns, global livestock trends, textile demand, and the availability of cheaper synthetic alternatives. Despite its smaller scale, the U.S. wool industry remains a key component of the national agricultural economy, supporting ranchers, shearers, graders, and processors who rely on stable prices and consistent demand. Understanding these material origins clarifies why wool still holds a $555.6 million market value in the U.S. It is not just an agricultural product, it is a globally traded resource shaped by biology, climate, economics, and international competition. The foundation of this industry is built on the simple but enduring process of turning a natural, renewable fiber into a product with high functional and commercial value. Once wool is sheared, it moves immediately into the collection and preparation phase, the stage where raw fleece becomes a structured, measurable commodity. Each bale begins as a mix of fibers, grease, lanolin, vegetable matter, and dirt. The goal in this phase is simple: convert loose, unprocessed wool into clean, classified material ready for industrial use or export. Intake starts at shearing sheds or collection centers, where fleeces are skirted to remove contaminants such as stained wool, burrs, or damaged fibers. Skilled handlers spread each fleece on a grading table, inspecting color, length, crimp, strength, and micron diameter, the key factors that determine market value. Fine wool with low micron counts commands premium prices, while coarser grades are directed toward carpets and industrial textiles. Once sorted, wool is compressed into standardized bales, typically weighing 400 to 500 pounds. These bales are tagged with origin information, micron testing results, and classing specifications. This traceability is essential for U.S. and international buyers who require consistency and quality assurance before the wool enters manufacturing pipelines. From there, the bales move to scouring facilities, where industrial washing systems remove grease, lanolin, dust, and plant debris. The scouring line operates through multiple hot water baths and mechanical squeezing units, reducing impurities by more than 50% and producing a cleaner, lighter fiber known as scoured wool. Lanolin extracted during this process becomes a valuable byproduct used in cosmetics, pharmaceuticals, and industrial lubricants. Some wool is further processed through carding machines, which align fibers into continuous sheets or slivers. Carding improves uniformity, removes remaining debris, and prepares wool for spinning or felting. Other batches skip carding and move directly to export markets, where overseas mills handle the remaining steps. This phase, collection, sorting, grading, and initial cleaning, determines the value of the entire supply chain. High-quality preparation ensures that U.S. wool meets international standards, maintains competitive pricing, and preserves market access in a global textile environment dominated by both natural and synthetic competitors. Through technical precision and consistent handling, the wool that began as raw fleece becomes an organized, ready-to-process material, setting the stage for the mechanical and chemical transformations that follow. The primary transformation stage is where raw wool becomes a usable industrial fiber. After scouring removes grease and impurities, the cleaned wool enters a sequence of mechanical and chemical processes engineered to standardize quality, enhance fiber performance, and prepare the material for spinning, weaving, or specialized manufacturing. The first major step is carding, where powerful rotating drums equipped with fine wire teeth separate, straighten, and align the fibers. Carding transforms loose wool into continuous strands called slivers, creating uniformity in length and structure. Precision sensors monitor fiber alignment and detect contamination, ensuring each batch meets strict micron and strength requirements. For finer applications, slivers move to combing, which removes short fibers and further refines the material. Combed wool, known as top, is highly consistent and ideal for producing high-end textiles such as suits, knitwear, and performance apparel. This step significantly increases market value by improving fiber quality and optimizing spinning efficiency. Chemical treatments may also be applied depending on the end use. Processes such as shrink-resist treatments, resin applications, or softening agents modify the wool's surface properties. These controlled treatments improve durability, prevent felting, and enhance comfort. All chemical applications must comply with environmental and safety regulations, particularly for export markets that require low-impact processing. Next, the wool enters spinning preparation, where slivers are drawn, stretched, and twisted to create rovings, precisely measured fiber bundles with uniform density. Automated stretching machines apply exact tension, ensuring the consistency required for high-speed spinning systems used in global mills. Throughout this transformation, data-driven controls track temperature, moisture content, fiber tension, and throughput rates. Modern facilities integrate digital monitoring that instantly detects deviations and adjusts machinery to maintain constant quality. This level of precision is essential for meeting the performance expectations of both domestic and international buyers. Economically, this stage is critical. The transformation from raw fleece to refined wool increases the product's value by 5 to 10 times, depending on grade and end use. The quality achieved here directly affects export pricing, competitiveness against synthetic fibers, and the ability of U.S. wool to compete in global markets dominated by advanced textile producers. By the end of the primary transformation process, wool has been reshaped into a controlled, predictable, and high-performing material. What was once a raw agricultural product is now a standardized industrial input, ready for spinning, weaving, knitting, or advanced textile manufacturing. Once wool has been carded, combed, and prepared, it moves into the refinement and forming phase, the stage where fiber becomes a finished, functional textile component. This part of the process focuses on precision shaping, structural consistency, and performance enhancement. The first step is spinning, where rovings are fed into high-speed spinning frames that twist fibers into yarn with controlled thickness and tensile strength. Adjustments in twist rate, draft, and tension determine whether the final yarn is suited for fine garments, upholstery fabrics, carpets, or industrial applications. Optical sensors and automated break detection systems ensure thread uniformity and minimize production loss. Next, yarn enters weaving or knitting preparation, where it is wound onto cones, beams, or packages. This stage organizes thousands of individual threads into structured arrangements ready for textile formation. Advanced winding machines maintain constant tension to prevent downstream defects such as uneven fabric strength or inconsistent patterning. For woven textiles, looms interlace warp and weft yarns using mechanical or air-jet systems. For knitted fabrics, circular or flat knitting machines produce continuous fabric panels with precise loop density and stretch properties. These systems run under strict environmental controls. Temperature and humidity levels must remain stable to prevent fiber distortion or breakage. After fabric formation, wool undergoes finishing treatments designed to enhance performance and appearance. These finishing treatments may include fulling to strengthen the fabric, dyeing for color consistency, softening for improved texture, anti-shrink or anti-pilling processes for durability, and pressing or calendaring to achieve smooth or textured surfaces. Each treatment relies on chemical balance, exact temperature control, and timed mechanical action. Automated systems monitor pH levels, dye uptake, moisture content, and thermal exposure to ensure every batch matches required specifications. Quality checkpoints occur throughout the forming process. Cameras and laser scanners detect fabric variations, surface imperfections, or color inconsistencies. Any deviation triggers immediate adjustments or batch rerouting to maintain product standards. By the end of this stage, wool has completed its transformation into a finished material, whether as yarn, fabric, or specialized textile product. These refined outputs supply a broad range of industries, from fashion and home goods to technical textiles used in filtration, insulation, and industrial padding. This refined forming process ensures that each product leaving the facility is stable, consistent, and ready for the demands of modern manufacturing. Every step reflects controlled precision, turning a natural fiber into a market-ready material with measurable value. Before any wool product enters the market, it must pass through a rigorous quality and testing phase, one that ensures performance, safety, and consistency across every batch. This stage verifies that the effort invested in sourcing, cleaning, transforming, and refining the fiber results in a product worthy of real-world use. The process begins in dedicated testing labs, where samples of yarn or fabric are measured for fiber strength, elasticity, shrink resistance, micron accuracy, color fastness, and moisture behavior. Specialized instruments stretch, compress, and expose materials to controlled conditions, confirming that each product meets industry standards and buyer specifications. These tests not only validate physical performance, they help maintain trust in U.S. wool as a reliable global commodity. Inspection teams then review the final output, scanning for visual imperfections such as uneven dyeing, inconsistent weave structures, or surface defects. Laser-guided systems and high-speed cameras provide precise detection that supports consistent quality even at large-scale production volumes. Once approved, the wool enters its broad range of applications. Fine yarn becomes high-end apparel and luxury knitwear. Medium-grade fibers move into blankets, upholstery, and uniforms. Coarser wool supports carpeting, insulation, and industrial textiles. Each category contributes to the economic sustainability of the U.S. wool sector, allowing multiple markets to benefit from a single renewable resource. This final stage reveals the true purpose of wool in modern manufacturing. Beyond its agricultural origins, wool remains a functional, biodegradable, and resilient material capable of replacing synthetics in many sectors. Its journey from fleece to finished product demonstrates the enduring relevance of a natural fiber shaped by skill, science, and careful stewardship. Through consistent standards and committed craftsmanship, the U.S. wool industry continues to deliver value economically, environmentally, and culturally. And as each product leaves the facility, it represents a completed cycle, a material transformed with intention, ready to support industries, protect consumers, and carry the legacy of American wool forward. From shearing sheds to global mills, the journey of U.S. wool reveals more than a supply chain. It reveals the resilience of a natural fiber and the people who sustain it. Every stage, from raw fleece to refined textile, shows how tradition and technology work together to preserve a material that has served humanity for thousands of years. In a world dominated by synthetic fabrics and fast production cycles, wool stands as a reminder that renewable resources still have a place in modern life. Its transformation highlights the value of careful stewardship, skilled labor, and the ongoing commitment needed to keep a $555.6 million industry moving forward. This journey also reflects something broader. Industries endure when they adapt, innovate, and remain anchored in purpose. Wool continues to thrive not because it's the easiest material to produce, but because it offers qualities, warmth, durability, sustainability that cannot be replicated by shortcuts or substitutes. From start to finish, the story of American wool proves that even the most overlooked materials can carry remarkable potential when shaped with intention. If this breakdown helped you see the U.S. wool market in a new way, consider liking, sharing, and subscribing, and tap the bell so you never miss another deep dive into how the world works, from start to finish.